Hello everyone, hope all you are doing good. Um, Today I'm going to show you a complete project. The project name is Movie Box Office Revenue Prediction using Linear Regression. Okay, so what we actually do in this project. Before going to the code, I am going to share you the background. Okay, so our main objective is investor actually want to invest money to making a new movie. Okay, so that they actually don't want to lose money. Everybody actually don't want to lose money. So that's why actually the investor request to the data scientist, that is the how much money I invest for a movie, and how much money I get back as a revenue, so that everybody actually like this type of equations before investing any money. Okay, so this is our actually the main objective. Okay, so why this project? I already described in a very short way. Okay, so what actually data scientists actually do, or how actually data scientists mitigate this problem? I'm not a data scientist. I am actually the software engineer. I am actually working as a developer, and also work as a data science type of project. So that's why I'm not very good in the statistics terms and terminology. Okay, so based on my experience, I'm just share you guys the all thing here. Obviously, please subscribe my channel, and I will share you lots of real life project that would be hands-on practice. So I request you subscribe my channel, so that you will get the notification whenever I upload a new video. So now come back to the point. So the data scientist, how actually they mitigate their problem? Number one, formulate the question. So they want to formulate a specific question, so that question will give you the actual answer. Based on that, you can easily identify how we actually going to or what is the way we can go for the solution, or how we can go for the solution. So if we formulate a question, this will be easy to address the way, what is the way we can go through. Now, data collection part. So I'll show you where I actually get the data, and then need to clean the data, because whenever you get data, there will be lots of garbage data. So you have to clean the data. Then explore and visualization the data, because it's very important part. So whenever you get the data, you have to explore the data and also visualize the data. You need to generate some chart, and based on that chart, it will be easy to understand the pattern. Okay, and then you need to implement some algorithm, that is the train algorithm, and finally you have to go for the testing and evaluate the algorithm. Okay, so this is actually the main process to mitigate the entire problem. So now I'm going to formulate a question. So in top view, I can say that is the how much can we earn from this money. Yes, it is meaningful, but this question is not very good to address the actual problem. Okay, so however, this how much revenue we get from this revenue, I mean how much revenue we can get from this revenue. So it is much better than previous one. Okay, but it's not the perfect question. I will show you why. So based why I actually tell you that is that those two question is not a perfect question, okay? Because to generate any revenue, investor needs some, they actually consider about the actor, maybe they consider script, maybe consider about the investing money for marketing, base director, etc. There will be lots of parameter out there, okay? But I just consider these three things. Just investor want to either considering the actor, maybe very high demanding actor, they want to involve their new project, I mean new movie, or this could be a very good script, or this could be they want to invest money for marketing, or want to hire a very good or best director. So this type of parameter they can consider, okay? But they can consider, okay? So the formulate question, because here I show you a chart that is the budget. X-axis it shows the budget, and y-axis it shows the revenue, okay? And there are some movie name I actually put there. And this actually, if I consider this chart, based on this chart I can easily understand there is a relationship between the budget and the revenue, okay? So based on this type of chart, I can formulate the final question like this: how much revenue can we get by investing how much money? This is much better question, because we know there is a relationship in this question. So what is their relationship? That is the, I already mentioned, that is the revenue and the budget. In this question, it's already treated, there is a revenue and the investment. This two word is very meaningful in the corporate industry. I'm telling you, this is very meaningful in corporate industry, okay? So that's why this would be our main question, or this is actually the much better question compared to previous two one, okay? So because why I am actually telling this, because this question, from that question and from this chart, we know this is testable, because there is a relationship between the movie budget and the movie revenue using our data. And I already told you I'm going to show you the linear regression. So that's why it's actually meaningful, okay? And here revenue actually called as a dependent variable, but this revenue actually in machine learning we call it target. But here the budget is actually independent variable, but in machine learning we call it feature, okay? So we have formulated the question perfectly. Now we are going to gather the data, that is the data collection part, okay? So here is the website. I actually take the data, raw data from this website, that is the numbers.com, and here you will get lots of movie like the budget and finance. If you go to the budget and finance, you see lots of data here. So I already retrieved all data, and also convert it as a CSV file. I also put the CSV file in my video description, so you can get this CSV file. So from our raw data, you know, there is a header, that is the rank, release date, movie title, production budget, worldwide gross, and domestic gross, okay? So for our simplicity, we actually consider only budget and the worldwide gross, okay? But remember, this is actually the raw data. So we have to clean this data, because why it is clean, why it need to clean this data, because there is a lot of zero value. Look, there is a lot of zero value. So this zero value need to remove. Why I need to remove? Yes, this this movie actually they they already invest to making money, making movie. Okay, so like this movie, they have their budget, that is the $400,000, but worldwide gross is zero, even domestic gross also zero. Maybe they already make this movie, but they don't release it. So if they don't release it, it's meaningless. So we have to clean this data. Okay, so I already cleaned this data, and how I clean this data I already mentioned in my previous video. You can go through that video. I also mentioned the video link in my description box, so you can also easily retrieve my previous video from my description box. Okay, so after the cleaning data, so clean data will be like this: only production budget USD and worldwide gross USD. So all are numbers right now. And if I go with the raw data, look, here is the dollar sign, and also the in header there is a dollar sign. Here it is the dollar sign. Also in number there is a dollar sign, so that I also clean that special character, because dollar sign is a special character. It will actually give us some pain during the work, because we have to remove that special character during our work. So that's why I am actually removing those special character, and finally I create this clean data. And now we are going to work on this clean data. Okay. Okay. Before dive into the code, I'm going to introduce some Python library. This library we actually use. That is the number one is pandas. So pandas is very popular library in data science world, and it's you can tell this is actually the necessary library actually for the data science project. Okay. And for the charting, we use the matplotlib. This is also very good and very well-known library for the plotting or charting. So you have to go through their official website, so that you can understand a lot more thing, because in a short video it's not possible to describe each and everything of matplotlib or pandas. Okay, so I'm just sharing you guys actually which library I actually use to solve this problem. Okay, so number one, I'm using the pandas, as I told you, and then matplotlib as a charting library. And finally, for the regression, I use actually scikit-learn. This scikit-learn actually very popular in machine learning world. Okay, so you have to go through this one, go through this library, and you have to familiar it, because whenever you go through their website and official documentation, it will help you more, because you have to expend your time on this website of their official website. Okay, so in a word, in a single word, I for solve this problem, I am using the pandas, then matplotlib as a plotting library, and that is the charting library. And for the mesh for the regression analysis and the testing and evaluation, I am using actually the
Okay,
scikit-learn,
to
which is
solve this
actually the machine
problem,
learning
I'm using actually the
library
Jupyter
in
Notebook
machine
extension in
learning
my
Python library
VS
actually.
Code.
Okay,
So
so
you know the VS Code is
now let's
ID.
go to the
This is the
code.
and it's very popular ID. And if you want to use Jupyter Notebook, you can use Jupyter Notebook. So same thing. And if you want to use I mean Colab, Google Colab. This is also same thing. So whatever the editor you want to use, you can use. So it's up to you. uh, but I like to use um, uh, uh, the extension of VS Code, because all control will be in my hand. But but if you're considering with the Colab and the Jupyter Notebook, yes, there is very advantage. There are already very advantage because they already preloaded library like pandas, NumPy, those type of library already preloaded or pre-installed. You don't need to install anything. But uh, I'm not like to do that because I want to control by myself. So okay, but it's up to you. Okay, okay. So first of all, in my previous video, I already mentioned that is I like to work in any Python-based project in the virtual environment, and how the virtual environment created, how actually virtual environment create, and what is the benefit. I already mentioned in my previous video, but I just I describe you very shortly. That is the number one. The If I create a virtual environment, this virtual environment actually a isolated environment. Okay, so whatever the library you actually want to use, all library actually installed in that virtual environment. That's why I'm actually using the virtual environment. So how actually create virtual environment, how actually create. So this is the way actually create. This is the Python uh, m virtual env, then name your virtual environment. I name my virtual environment like env. If you want to name this virtual environment like my env, that is also possible. Whatever you want to use, you can use, so no problem. But I already create this virtual environment. But when the command I execute, then uh, this extension will be, I mean, this folder will be created. And if you are a Linux user, right now this project actually developed in my Windows PC. And if you want to use a Linux PC or Mac OS, then only the difference is the in Windows this folder is named as the scripts, and Linux and Mac OS, this is actually bin. Okay, this is actually the bin folder. So why I am actually telling this, now you can understand. uh, I already created the virtual environment. Okay, so I need to active this virtual environment. How I actually active this virtual environment script active, that's it. Look, here it is, the virtual environment is activated. Okay, so whenever the virtual environment is activated, so it will be prefixed with your name of your virtual environment. Okay, and if when you want to deactivate your virtual environment, just deactivate, then it will be deactivated. Okay, but in windows, in Linux and Mac OS, to active the virtual environment, the command is like this: source, sorry, source, then env, in name of your virtual environment, then bin, then active. If you execute this command, the virtual environment will be created, and rest of the things same. Okay, now I'm going to active my virtual environment. Env script active, it's activated. Okay, very fast time, very fast. Okay, you have to familiarize with this id, that is the Jupyter Notebook id. This is all our cell based code. Okay, so whenever you actually write your code, all are actually in a cell, so that it is very easy to manage. It is very easy to manage, easy to identify where actually what cell, what functionality actually hold, or what functionality you actually execute. So it's very, in a word, it's very too easy to identify or manage or whatever it is. So now, if you want to, it's actually, if you want to any comments in this cell, there is a two-way you can comments. One way is this way. So this way, this will be, this also execute as a comment. Okay. And if you want to know, I don't want to want to I just want, I want to add a markdown that is like this. I'm just show you, so that you understand. So there is a column, that there is an option, that is a markdown, and this is the code. If you add this code, then this cell will be treated as a code cell. But if you want to add as a markdown cell, this cell is treated as a markdown. This will not execute your code. So there you can mention like this. Here it is markdown, down, not code cell, markdown cell. Okay. So look, the look and output is look like a Microsoft Word. So here, so in a word, if you want to, if you want to write something about your code, then you can use the markdown, and when you write the code, then use the code cell. Okay. Okay. uh, Delete it. Okay. Okay. Number one, I am actually importing the pandas library as a import pandas as PD, and the PD as a alias, and you have to use this alias because it will it's actually the common practice. Okay. And from pandas I use the data frame. Okay. So I, because I need to create some data frame for executing the algorithm, also executing the chart. Okay. And I also use the matplotlib, and matplotlib there is there is another sub, you may call it the sub library. Okay. Of Sub library of a matplotlib. Okay. So matplotlib, there is a pyplot, and we name this package as a, I mean this library as a PLT. This is the actually alias of the pyplot. Okay. You can name it anything, but PLT, this is actually the common practice. Everybody actually use this type of term or this type of alias. uh, okay. And finally I'm using the scikit-learn, and in the scikit-learn I use the linear model, um, and import as a linear regression. So this is our complete library I use. But you have to execute this cell because if you don't execute this cell, you can't work in next cell. Okay, so this library will not reflect it in the next cell, so you have to execute. So how it actually execute? Shift enter is very easy. Now it's executed. Okay, now I'm going to read our clean data. That is the, and that clean data I want to put in as a object. So let's declare a object, that is the, I call this object as a data pd dot read csv. Now, sorry. What is the clear data? That is the cost revenue, and cost revenue, clear data, clean CSV. Okay, fine. Okay, so here I actually read this CSV, not CSV. It's actually I need to add the CSV file. Yes. Okay, here I already uploaded my CSV file. Here it is. I just uh, zoom in so that it will be clear. So how I actually read the CSV file, that is the using this pandas library, and using pandas library and read.csv. CSV is actually the method. Then I just put here the file name, that is the here it is the file name, that is the cost revenues clean.csv. This file name I actually write on here. So whenever I just execute this cell, so here when I actually execute the cell, what actually happen? Uh, all the CSV file actually right now hold in this object name data. Okay. Now I need to give you some output, basic statistics output like this data. Look, this is actually the I describe this data. Okay, so what actually do? It is actually the very common practice. All statistician actually use this function. So what actually describe, that is the it shows the total number of rows. Number one, this number will give you some funny number, right? It's actually the scientific number. Now if I copy this number and paste it this cell and execute this cell, then it will show the 5034 rows. This is actually the rows. Okay, this is actually the rows. So yeah, so in CSV file, this CSV file is in total there are 5034 rows there. Okay, and the mean value, which is actually the average value of the budget. If I execute this is actually the average amount for the budget, and for the gross profit, this is actually the average gross profit. I'm just showing you, but it's not very important thing. So you can, it is very easy part. Okay, so mean means it's actually the average, and this mean, that is the mean, mean. This is the minimum. That is the lowest value. That is the lowest value. So lowest value of this data set, that is the for the if I consider about the budget column, then the minimum budget was 1100 USD. Okay, and the minimum revenue was like this, but its minimum revenue was only 26. Okay, so this is actually the basic statistics, nothing else. um, Now what next? Okay, okay, as I already mentioned, that is the we are using a data frame because uh, we need to define some data frame, like for the for the plotting point of view. Okay, so plotting point of view, I mean chart. There is a x-axis and there is a y-axis. I already show you in my in very beginning of this video. Okay, so I need to set a data for the x value and the set a data for the y value. So in this way we actually define a x-axis and a y-axis. Okay, so how we actually do, that is the number one. I define a x value, that is the x value, and we define it is actually data frame. And in data frame I actually put the and I actually referred our data, that is the I uh, already mentioned here as a object. So I pass this object, and in object I know there is a column, that is this column. I want to I want to put these columns value as a x axis value. Okay, now I'm going to put the data frame for the uh, the data. You can data is equal to data. It is also possible, so no problem. Column is equal to what is the column? Worldwide gross. This is actually our revenue column. Okay, this is actually the revenue column. Okay, nice. Now shift enter. Okay, fine. So if there is a if it will give some error, then it will be red cross, but it's success. That's why it's showing the green right sign. Okay. Now I'm going to plot. I'm just going to generate the chart. Okay. So let's generate the chart, and for to generate the chart, I'm using the matplotlib, and the alias was the plt. Okay. So plt dot scatter, sorry, scatter, then x value, then y value. Okay. Then plt dot show. Okay. Show. Okay, look, here it is, here it. Now we get some output. Now we need some work on this. Okay, number one, what we need to work, because this image actually give you the very small image. So I need to work on the one one to big representation. Okay, figure fixed size is equal to uh, just want to 10 6. Okay, let's show it now. It shows the pretty much good. Okay, so it's pretty good right now. So now there is a there we need some add some element like the chart title or x-axis title, y-axis title, this type of thing we actually need to work on. Now I'm going to add some label, that is the chart name, and the x-axis title, y-axis title. So how it work? How actually? So let's do it. Um, so let's do plt dot x level x level. We call it like production budget. Yeah. Okay. Production budget. Yeah. I hope the spelling is okay. And then the plt dot y level, we call it like um, worldwide in the worldwide gross gross, then dollar sign, so it will be more meaningful. Yeah. One thing I just missed, the enter chart title I want to use, that is the plt dot title title. What we can name this title like um, film cost versus, yeah, that could be good. Right? Film cost versus gross 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 revenue, anyway. Okay. Okay. Now let's go for the hit enter, and let's show. Look, here it is. uh, x-axis level is a production budget, and y-axis level is worldwide gross, and the entire chart title name is the film cost. Yeah, cost, cost. Yeah, yeah, film cost versus gross revenue. Okay, fine. So in this chart there is a problem. Look, there is a gap between the, if you consider the y-axis and then x-axis there is a white gap. Okay, so we need to mitigate this one because it looks very odd, very odd. Okay, so how we actually we actually do this do to fix this issue? We will um, limit the x-axis and y-axis. How actually limit? That is the plt dot x limit start from 0 to, if we consider the x limit, this is the 4, I mean 4.5. Okay, that means 45 billion. Yep. Okay, and um, in the yplt dot ylim start from 0, then there's a 2.5, and we consider the 3 billion. Yep. 1 2 3 1 2 3 1 2 3. Yeah, that's it. Hit enter. Now it shows. Yeah, look. Now the white space is gone. White space is gone. Okay, white space is gone. Now it's look good. Now we need some extra work to visible this dot. Okay, uh, so right now we can't. It shows the density. It's okay, but if we give some another property, scatter, yeah, scatter here, like alpha property, that is the is, alpha is equal to 0.3, then it will show more beautiful. Yeah, now it's more beautiful. Now it's clearly visible the density area. So this is actually the Avatar movie. That's why this movie is completely out of the world. So budget is high, revenue is very high. So, but if you go with the density area, so it will give you some idea. That is the how much want to invest, and how much can be your revenue. Okay, so now come to the um, very interesting part right now. And now we are going to regression. We are going to implement the regression analysis, the linear regression. Okay. Now, now we are actually implementing the linear regression. As I already mentioned, that is the from very beginning I already import the linear regression library in my top cell. So in my virtual environment already the library is installed, and already library is uh, ready to uh, use. Okay. By this time, though I already mentioned, that is that I use the virtual environment, so that you have to install the pandas, scikit-learn, and the matplotlib in your virtual environment. So how we actually install that, I forget to show you. That is the pip install pandas. If you run this command, it will automatically install in your virtual environment. In this way, you just use your matplotlib. In this way, you also scikit-learn. Okay, so in this way, you just the same thing, pip install library name, pip install library name. So it will install in your virtual environment. So I already installed it. That's why, and how actually install the library, I already mentioned in my previous video. You can go through there. So now come back to our point. Okay, so I'm going to create an object named regression equal to linear regression and regression. Uh, sorry, regression. Sorry, I just okay, yeah. Sorry, so the typing mistake. Linear regression, and that's it. Okay, what I feed, that is the I already declare a data frame for the x value and the y value. Okay, so I'm going to feed with the x value and the y value. So what I actually do here? Okay, this is actually the like a container. Okay, so so x value and y value I just put in a container to calculate the linear regression. This is actually the bird's eye view concept. Okay, I'm going to I'm going to show you the coefficient because it is very important to to know the coefficient value. Okay, so what is the how we actually get the coefficient value? Regression dot coefficient coefficient. Okay, okay. Okay, look, very important thing, underscore. Underscore is very important. This is actually the necessary. Okay, okay. So look, the here actually the coefficient value is positive. So, so it is very important, and that is it shows us yes there is a relationship. There is a relationship. If there is a negative value or this, then the data set will be very bad. It will reflect as a very bad data set. Okay. Okay, now I'm going to intercept because coefficient and intercept is very important. Okay, so intercept, how we actually identify the intercept? The same way, regression dot intercept. Look, intercept is this value, that is the minus 72,000. I mean, yeah, just this is the actually intercept value. So intercept value, you know, if you go through the statistics term, then you understand what is actually the intercept and what is the coefficient. And I'm not sharing you guys the statistics terms or that type of thing. I don't want to share you, and I'm actually completely focusing the technical point of view, how you actually get that value. So it will help you during your code. Okay, so I get the coefficient and get the intercept, and coefficient is positive value. That means there is a good relationship. So what I am going to do, I just use this code base again. I just use this code base because I want to draw the slope, because for the linear regression you have to draw a slope. Okay, so I will show you here. Okay, there is a function in matplotlib, that is the we already give the alias, that is the plt dot plot. Okay, plot x value of regression dot predict x. Okay, fine. Here it is. This is the slope line. This is a slope line. Okay, this is, it will show you a relationship. That is the, you don't need to consider the uh, top top bubble or the eh, this bubble, or you just consider those bubble who are near to this slope. This will give you a confident, that is the, if my budget is like 2 billion, then could be I will get the revenue like 1 billion. Okay, that means if you invest 1 billion, then there is a possibility uh, to return as a revenue 0.5 billion. Okay, again I'm telling you like this, if you want to invest like 3 billion, after all the cost, all the everything, then there is a possibility to get the revenue like 1 billion. So in this way it will shows you like this, if you consider the 3 billion, you just the production budget is like 3 billion, and this slope value in y-axis is near to 1 billion. Okay, so it will give you a positive result like this. You can feel confident this, yes, I can if I invest 3 billion, then yes, the profit will be, I'm telling you the profit, I'm not telling you the everything, I'm just telling you the profit only. Okay, so the profit would be 1 billion like this. Okay, so so that's why this slope actually very important to know. So now is better, give some color code, and it will look good. That's why. So like this, color is equal to red, and line width is equal to 4. So it will show you a red slope. Just give you some idea how we actually colored this slope line. So we almost complete. Uh, Now the final part of this project, that is the what we actually get the data, and we already plot the data, and we already chart draw a chart already. Okay, so now our this is our now the final part for the data science workflow. If I consider about the data science workflow, we need to test and evaluate. Okay, so for the testing and evaluate our algorithm, we use a R square, and another name of this is R square is called goodness of fit. Okay, so how we actually use this R square. Okay, so then we actually get some score, that is the how much percentage actually give you a score based on this data set. So any statistician will give you a very good definition, but I'm not actually the statistician, but I know actually why this is required. Okay, so after I implement this algorithm, I need to verify or evaluate or test my algorithm how percentage is good or bad. Is it below 50% or below uh, or 50% plus good data set? So that if it is a 50% below 50%, then I must say the algorithm is not good. Maybe there is a problem with the data. There is a problem with the problem with somewhere. Okay, so let's evaluate our algorithm. Regression dot score x value and y value. Look, it is near about 55%. um, it actually give you a score as a 55%. Okay, but it shows you 0.5496, but it actually shows like this way. If I like declare a variable like score is equal to something like this, and final, see, or just name this very well, nothing else, for easy understanding, nothing else. Score into 100. Okay, now final score. Oh, sorry, final score, final score. Yeah. Oh, now now you can understand that is actually this if I print this value also the same thing will be when I print this value, that is the 0 0.9 and 0.5496 something like this, and after the multiplication of 100, that is the give you the 5.4 something. So I'm just but same thing. Those are both are the same thing. This will refer as a percentage. That's why I am actually multiply the 100% so that it will give you a more visibility. Maybe it will give you some clear picture, that is the how percentage. Yes, how my percentage is like near about 55%. Okay, near about 55% accuracy rate. That is the good data set and good algorithm we actually pick. Then more data, if you calculate with if you consider about the more data set. Right now I am using only 5034 rows. So if there is a rows about 1 million or one or two or 1 billion or 2 billion or 3 billion rows, then the accuracy rate will be more good. Okay,
I
so
will show you in the in my next video. I will show you more interesting videos, and those are also real life projects. So and I request you please subscribe my channel and support me. So it will help me a lot. Thank you everybody, and I hope we'll see you in my next video. Thank you.